Okay, everybody, thanks again for joining for the second session of presentation run by David Galvan on bridging the gap between your DCS and your field instrumentation. If you're just joining us now, the first hour we spent on looking at Honeywell PMC field instrumentation line and integration into your DCS through FDM. David, in the second hour now, is going to talk a little bit more on the ControlEdge family and some other products as well. I will pass it over to David at this time. So thanks again, David, for joining us. And once again, all of these will be available as recordings. If anybody has any questions, I will be trying to mute the crowd, pass them through the comments tab, and I'll try to monitor them as well as David, and we will answer them at the appropriate time. So thanks again, and I'll pass it over to David.
Hey, thank you. I appreciate that. Thank you guys again for joining session number 2. For those of you who are on session number 1, we focused on instrumentation. Now we're going to focus on the modular systems offering that Honeywell has. We'll talk about Experion. We'll talk about the ControlEdge RTU. We'll talk about the ControlEdge HC900 or Hybrid Controller 900, and then the ControlEdge PLC, which is right now the focal topic of today's session. We're going to talk about it, utilizing it standalone, and also talk about the ways you can use it into your Experion system. Okay, and again, just like the instrumentation, it's going to be an interactive session with demos and such. So we'll make the best out of it. All right, so the first thing that we're going to talk about is Experion LX. It's a channel-ready DCS that we have. It's basically Experion PKS little brother or small sibling. It's designed for smaller systems. Okay, but it's identical to Experion PKS. So if you have a small plant, small facility, you don't need the density of all the I/O points and tags. We have our own DCS here, Experion LX, and this LX is delivered through channel partners. Okay, it's a complete DCS and SCADA system all in one, just like Experion PKS is. One controller can handle 10,000 process tags and 115,000 SCADA tags. So it can grow as you go. You can connect all the systems together, up to 11 systems together, and as much as you need. But one cluster can handle 11,000 or 10,000 process tags. Okay, and just to kind of give you the differences here, one cluster of Experion PKS can handle 50,000 process tags. So just keep that in mind here. But it's a full DCS complete solution. Same tools as Experion, same HMI web builder display graphic design, same library containment, same function blocks, same integration into everything. The only difference is here, you do not have universal I/O capability with Experion LX as you do with PKS. Okay, but you can integrate a UOC into an Experion LX architecture, or you can integrate a PLC that has universal I/O to accomplish that. So complete DCS and SCADA, powerful C300 controller that's been around forever. All right, since the early 90s, late 80s, early 90s. It's a supervisory system, peer-to-peer, with direct connectivity to your stations. So that's the difference between a SCADA system, a full SCADA system, and a DCS, right? So with a SCADA system, your point repository is being done in the server, and that server, right? That SCADA server. So if you lose your server for any reason, you lose view. You don't lose control. You can, but your control is being done at the PLC level. Your view is gone. With a DCS, this controller here is connected directly to the station. So you never lose view, never lose control. Okay. And you can also have SCADA devices connected to this system as well. Okay, so it's a 2-in-1. So when it's all said and done, your whole build out can be as big as this. So you have your C300, you have your different protocols, you have HART, you have Foundation Field Bus, Profibus, you have one wireless. So if you want to integrate wireless into your system, you can bring that into your FTE, fault tolerant Ethernet line. And again, FTE runs with Experion PKS and LX. Okay, fault tolerant Ethernet. We've had it for a long time. And then from there, you can integrate your ControlEdge PLCs, the ControlEdge HC900, the ControlEdge RTU, your Master Logix PLC. So this is for high acting 42 nanoseconds of speed logic, maybe for food and beverage or for auto production or robotics. Okay, and then you can also bring in your safety system, so your safety managers can come in here, your Experion panel PCs, whatever you need to integrate, you can bring it in to your level 2 line here, supervisory control network. And then your level 3, 3.5, your advanced applications, you have the same integration with FDM, what I showed you on the first segment of the demo today, Field Device Manager for asset management. You have eServer for web-based graphics, view-only type things. You have the PhD, Process Historian Database Collector for historical analytics or uniformance. You have DVM for any kind of video management that you want to bring in with analytics. You can bring that into the system. You have Experion stations, remote operations, and then you have all of your advanced process softwares here, Unisim, ProfiSuite, you name it, Dynamo, everything that Experion PKS has, Experion LX also has that same ability. Okay, and then earlier when I spoke about the direct station, so this is it here. So you have your direct station that would be directly connected to the C300. So again, you never lose view, never lose control. And then if you just want a flex station that flows through the server, you can have that as well. Okay. Experion, the ControlEdge PLC, the ControlEdge RTU are fully capable of simulation. So I can simulate the C300, I can simulate the ControlEdge PLC, I can simulate the UOC, the Unit Operations Controller, I can simulate the RTU. So again, you can do all of your engineering, your programming, your testing way ahead of time, way before you have the hardware in your hands. And then once you prove that, you can dump all that logic into the physical attribute. But more importantly, as you go forward, with the life of the product, you can actually use simulation for testing. You can use simulation for training your operators, training your technicians, and you can air gap that. So now you don't have to worry about, oh, okay, yeah, we're on the live system conducting a training and something happened, we spoofed up the system. Well, you can eliminate that by utilizing a simulation offline system that is only used for training, only used for testing. Okay, so we have that ability as well. Everything is fully simulation and fully virtualization as well, ready. Here we talk about our FTE, fault tolerant Ethernet, okay, and how it works. So as you can see, here's one line of communication. So you have your A to A path, you have your A to B path, you have your B to A path, and then finally your B to B. So it's a quasi path system. You have 4 paths of data that can flow through a redundant system that you see here. Okay, we've had FTE for a long time. It's proven, it's well used around the world. All these systems that you see here are well used around the world. Yes, we have a lot of new systems, a lot of new names, but the core technology is the same. We probably upgraded a lot of functions and features, but for the most part, the core technology it comes from TDC 3000, from our first DCS that hit back in 1981, 1979, TDC 2000. Okay, so well-proven equipment here. Now we'll start with the ControlEdge PLC, or secondly is ControlEdge PLC. Okay, ControlEdge PLC, powerful PLC that has the ability to utilize 4, 8, or 12 slot chassis racks. Okay, you can have a system up to 2300 IO per PLC, so per CPM. This slot you see here is a CPM, Central Processor Module. Okay, that processor module can handle up to 2300 IO per PLC. That's what we consider a PLC, CPU. Okay. You can have 4, 8, 12 slots with that. You can via star, via ring, you can expand that. You can lay out remote IO wherever you need in the plant, and then you can have your CPM either redundant or simplex in your IER, ECR, MCC, server room, wherever you need it to be. Okay, very powerful there. It comes in 2, and I'll show you here in a minute in the next slide. It comes in 2 forms and fashion when it comes to your rack and then your CPM rack. So your IO rack and your CPM rack can be fully detachable, where you have your CPM rack in a central location, and then you have your I/O rack spread out via that ring or via that star in remote areas. ControlEdge Builder tool is one common tool that we use across the RTU, across the PLC. All right, so what that means is now if you have the need for a small prepackaged PLC with the ControlEdge RTU, you can put that out in a remote tank farm area or on a well pad, wherever you need it to be, and then you can bring that information back to Experion. Now the tool to configure that is the same tool that you'll use to configure this PLC. So it's one common platform. Okay, so when it comes to continuity, everything is there. You have one platform, one set of tools, one training, you name it, for the PLC and for the RTU. The ControlEdge PLC also complies with IEC 61131.3. So you get all 5 programming languages. You get ladder logic, you get function block, you get sequential function chart, you get structured text, and you get instruction list. So if you're a site that likes ladder logic for whatever reason, and all your guys are trained on ladder logic, you can continue to use ladder logic. Okay. If you're on ladder logic now and you wanna go ahead and say, you know what, everything is function block, the rest of the plan is function block. Let's go ahead and try to make our PLC networks also function block. We can do that. We can transition all of those ladders. If you have an obsolete PLC, if you have a PLC that needs to be replaced, we have transitions tools that will transition your current ladder logic into either a ControlEdge ladder logic or ControlEdge function block. Okay, all that's there. The ControlEdge PLC was and is, I still believe, the only PLC on the market today with ISA 99 compliance. So it was the first PLC on the market to be ordained with IPsec ISA 99 for cybersecurity. Okay, so it has embedded cybersecurity. For those of you who are currently using Experion, we have an embedded CF9 in here. The same intelligence that's in your Control Firewall 9 on your Experion system is the same intelligence that resides in here, that resides inside the CPM. Okay, there's a firewall, meaning that I cannot ping this device. I cannot ping this device. I need the software to program it, that encryption, that handshake from this ControlEdge Builder tool to this PLC. Embedded OPC UA. Yep, we have that embedded OPC UA. We have EIP, Ethernet IP. We have OPC UA. We have DNP3. We have standard OPC. We have standard Modbus. Whatever protocol you need, we have for this PLC. And then we have those cards that go with it. Okay, so if you need, say if you have a piece of equipment out in the field, it's an ASCII RTU, it's an older style 232. You want to bring that data into a PLC and then connect that PLC to a peer-to-peer connection to Experion. We can do that. We can do it to any device you have out in the field. Okay, we have customers right now that are, because of the integration to Experion, we can bring in devices and let this ControlEdge PLC be the gateway, be that divine gateway that eliminates a lot of that kludgy software connections that we're currently using today. We can use a physical hardware peer-to-peer gateway into Experion. 20 milliseconds of execution time. Okay, the C300 runs at 50. This guy's at 20 milliseconds. So fast acting for discrete I/O control. Okay, and then we also have the HMI third-party device integration via all the Modbuses that I spoke about earlier. All right, so the two forms and fashion, again, if you're going to use a redundant CPM, central processor module, then you would utilize this rack. And then this, instead of it being a CPM, it now becomes an EPM, extension processor module. So basically what you do is you connect your uplinks and downlink cabling, either star or ring, to your I/O rack, and this will be your remote I/O rack out in the field. This box will be in your ICR, ECCR server room, wherever you need it to be, handling that function, okay, as the CPM. The integration into Experion, PKS, HS, and LX is via OPC UA. We also have CDA, Okay, so for those of you who are familiar with controller data access, we do have CDA ability. So you have OPC UA, we have CDA, and then we also have Modbus TCP. If you just want to connect it Modbus, we have that ability as well. Very powerful stuff. And then one cool thing that we've added here is this Experion panel PC as a perfect match. So with this Experion panel PC, I can connect it directly to the PLC. Okay, you have your same graphics that you would see in the control room. Okay, it's one shared repository, connects to the FTE. With this Experion panel PC, I can also view all the diagnostics coming off the PLC, all of the graphics that are tied to the PLC peer-to-peer, meaning that when I build the logic inside this PLC, either if I use this panel PC or Experion PKS, I can push one button. It's called Publish to Experion, and I'll show you that here shortly. It will publish all of the tags that I wrote in this PLC to Experion automatically. Okay. The PLC also has universal I/O. So every card you see here is 16 channels of universal I/O. I can software program every channel to either be an AI, an AO, a DI, or a DO. And the cool thing too, every channel, all 16 channels, every one has its own HART dedicated MUX modem on it. Okay, so now I can access, interrogate, configure that instrument that's connected to that channel utilizing FDM, okay, through OPC UA HART IP. Now, the one thing that's different from this PLC and others is that HART onboard integration. Now I do not need any kind of interface MUX card. I don't need an adapter card. Out of the box, if you use your universal I/O module, it comes with that HART IP. It comes with that HART integration. Very, very powerful stuff. Okay. And then another thing that we added, because we have the HART card, we also have in the configuration side, we have the ability to use the 48 HART command function block. So if I want to use the secondary variable, and I want to strip that HART data off of that device and actually use those variables for control, I can do that. I can assign those variables in that logic block utilizing that 48 command block, and I'll show you that later in the presentation. Really, really cool stuff. So standalone, you can use it standalone. It'll work with any other SCADA software that exists today, utilizing Modbus TCP, OPC UA. It connects to it just like it would any other PLC would. You can use it bundled with Experion. You can get all the benefits of the integration. You can use it standalone if you do not have any software at site. If maybe you use, you have a lot of little control boards all over the place. You can use another option is use the PLC with the panel PC, or altogether. You can use a panel PC with Experion, PKS, HS, or LX connected to the PLC. If you're a facility that does not use Experion, you can use it standalone with your current process control software bundled with this panel PC out in the field. So there's various ways that we can mix and match the solution to fit your needs. Okay, here's the HART function blocks I spoke of. And then also all of the function blocks that we've had in the industry forever, since the 1980s, we've included them in the library of the ControlEdge PLC. Okay, so if you're a current Experion user, all those function blocks that are in Configuration Studio in the library containment, they are also inside the ControlEdge Builder software. So same library containment, same tools, same function blocks, the DACA blocks, you name it, everything is in there. Okay. Here it talks about the IPsec or ISA 99 compliance. Now, just to kind of make you aware what this does, what IPsec is. IPsec is IP security, meaning that if it protects you from middleman attacks, And what that usually entails is someone, you don't have to be a genius to do this. If I was able to ping this PLC, okay, if I can ping it, if I can just do a run command ping 192.168.168, the IP address of the PLC, and get a reply back, then me, I'm not a genius, I can write a little batch file that states, hey, I want you to ping this IP address every 2 milliseconds for infinity. That's basically going to bog down your network, and it's going to basically shut down that PLC. Okay, we have people doing that. But because we've incorporated this IPsec, authentication and encryption, into the firewall of the PLC, you can't ping it. You need the software. You need that ControlEdge builder software. And that's for both the PLC and the RTU. Okay. So for when it comes to security, we're there with the PLC. Now, here's if you're using Experion with release 500 and greater, we've included the ControlEdge software already in your software build. So when you build your Experion system, you have ControlEdge integration already there. Okay. So this ControlEdge builder that you see on this side, and this is Configuration Studio. So this is what you currently have if you're an Experion user, Configuration Studio, and this is the software that it's going to pull up. And I'll show you this shortly in the demo. So the software that we use to configure the PLC is ControlEdge Builder. Okay. Now, once I build my logic in here and have it all ready to go, I don't have to go into Experion and rebuild all that in Quick Builder. I don't have to do that. All I do is click this Publish to Experion. It'll send all of the tags, all the registry. It'll send it over to Experion. And then in Experion, all I have to do is generate the ones that I want. I may not want all the diagnostic data tags to come in. It may be a nuisance alarm. I can ignore those, but I can go ahead and generate all the ones that I want with a one-shot approach, saving tons of time, okay? And it maps everything the way it needs to be mapped, the right memory file, the right buffer, the right IEEE buffer, either 16-bit or 32-bit integer. It does all that for you. It recognizes that for you. Okay, very powerful stuff, and I'll show you that here shortly. All right, the HC900, the hybrid controller 900. This device is very popular, and we have many installations of the HC900. It is popular in the burner management world, combustion world. Okay, very popular there. I mean, you can use it for anything. So the HC900 is a pack. It's a programmable automation controller. It's a hybrid between a PLC and a DCS. Okay, it does have its own software. See the Control 900 station that you can connect to it. It's peer-to-peer connected to that, but it also has universal inputs and universal outputs. Now the difference between this and the PLC, this is safety rated. This is a SIL 2 system. Okay, so if you need a safety manager, this is good up for a SIL 2. All right. Again, it's only function block because it's packed. You don't get ladder, none of that stuff. It's solely function block, but it is SIL 2. All right, HC900. Now the next one in the ControlEdge family is the ControlEdge RTU. All right, ControlEdge RTU is a small prepackaged RTU that's good for up to 500 I/O. So I can connect an expansion slot here and continue on with my I/O channels. Okay, right off the bat, I get flexible communication. So on the top, I have two 485 ports that I can bring in slave devices, master or slave devices in. I have a couple of RS-232s. I have IPsec compliant and firewalled TCP/IP connections. Okay, it's good for -40 and 167 degrees F, so 75 degrees C. All right, so designed for harsh environments. It also has HART embedment in every AI and AO channel. So the one prepackaged module set that you see here will give you 8 analog inputs, 2 analog outputs, 11 discretes, and then 2 pulse inputs. You can mix match the discretes. There's DIs and DOs. Okay, it is a full-blown flow computer. AGA complies with AGA and API. It has all the flow algorithms inside for Coriolis, for turbine, viscosity, you name it. Everything is there. Orifice, you name it. And then it also has wireless I/O ability. So now what I can do is I can take an FDAP, a field device access point. Basically, it's this right here. Let me just show you what it looks like. I can take this here, field device access point, and I can connect it to the RTU. Here's the RTU. And I can bring in these wireless transmitters through the RTU. So I can have a combination of wired instruments connected to this, and I can have a wireless instrument, or up to 25 wireless instruments connected to this. Here's a real life scenario where an RTU is designed basically to run off batteries in a remote area. Most likely there is no power infrastructure in place. So what we've done is we've done a lot of really hard engineering spec work on the power draw. At full utilization, this RTU only draws 2.9 watts of power max. Okay, that's at full utilization. Now think about this: when it comes to power in a remote area, if you use a wireless transmitter, it is also self-powered up to 5 years. Now you have a fully efficient power system because the RTU is utilizing its own power of 2.9 watts off batteries and solar, and then your transmitters are also using its own power source with the battery. So really nice combination there. Okay, so here it talks about some physical aspects. We talked about the 485, the 232, the E ports. We also have here below, there's an SD slot for memory expansion, and you can add up to 64 gigabytes of expansion here on the, and then on board it's 64, so a total of 128 gigabytes of memory. That's a lot of onboard data logging. Okay, this device has an onboard historical data logger on board. Okay, so if something happens, you always have your onboard historical data, and it also sends it via DNP3. It has DNP3 capabilities, sends it to your host system. And if something was to happen with your communication, maybe you lost comms for a day or a few hours, the data log is being stored here locally. With DNP3, I will storm forward you all the information back to your host system automatically. Okay, so we have that as well. And then here on the right is the expansion slot. With that expansion slot, we can add more I/O modules, up to 500 I/O, and we can remote mount that or however you need. Okay, so this is the ControlEdge RTU. Now, when it comes to programming for both the PLC and the RTU, we have the 61131.3 programming IEC. So it's an open standard. We comply with that open standard. That gives you that ladder logic, that function block program, structured text, instruction list, sequential function chart. Okay, it's really cool too when it comes to firmware upgrades with the RTU. If, for instance, I want to upgrade the firmware, I do not have to wait there. Okay, so the way it works, we all know that flashing the firmware can have its flaws, right? So if there's an interruption, you can break the unit. You know, so many things can happen. Now, the way we manage that is when we want to upgrade the firmware for whatever reason. Remember that this is in a remote area, slow network. You know, you never know the situation there. The way it works is from my host system, from ControlEdge Builder software, I am going to send to that RTU the firmware upgrade package. Okay, when the RTU receives that firmware upgrade package and says, David, I have it in my possession, then on its own, it'll go ahead and invoke the upgrade there locally versus over the net. Okay, so that eliminates any suspect flaws in bricking of the RTU. You also get all the online diagnostics. You get data log upload, all your intuitive workflows. You get it from the RTU, and I'll show you that here shortly. Very powerful device. So this is what the RTU would look like with the FDAP, the Field Device Access Point, utilizing wireless instrumentation. Okay, just like that. Really big in the upstream world. And when it comes to gas and liquid flow calculations, we have the embedded flow wizards inside for flow computers for AGN API and ISO. So everything is there. Okay. And then this is what it would look like, you know, coming out of a solar kit. You have the RTU, the radio, your HMI, any kind of local subsystems that you would use, and of course your instrumentation here. Okay, and on the top layer, you have your Experion, you have FDM, because again, we have FDM ability through this, and then your production management software. Okay, that's about it on the modular system side. I am now going to start the demo, the online demo. And for this demo, I'm going to be utilizing this ControlEdge you see here. Okay, and also the RTU that you see here. It is connected to Experion with the DNP3 integration protocol, and I'll show you where that exists. First thing I'm going to do is let's go ahead and get into the software. Okay, so I'm going to open ControlEdge Builder. Okay, so here's ControlEdge Builder. This is software that you would use to configure the RTU and the PLC. Once you have the software, what you do is you hit connect. We have a nice tool here that will scrub the network and will locate your devices here. My system that I'm currently connected to, I see 2 devices, which is correct. I see the PLC and I see the RTU. Let's go into the PLC first. Okay, it gives you a really nice description here of the IP address, even serial number. So really nice for asset management, asset tracking, firmware rev, the redundancy role and status, and configured slots. I'm going to log in as an administrator. Okay, so I know my login here. Let me go ahead and log in. Connect. Okay, I'm connected. Operation mode is running. Okay, let's open a project. Well, before I open a project, I want to show you what you can do even without a project open. Okay, so without a project open, just connected, I can view diagnostics of the PLC. Okay, right off the bat, you get all your PLC diagnostics and statuses. You get CPU utilization, you get serial number, you get temperatures, CPM temperatures, you get all this cool stuff. Enclosure temp, okay, network statuses, you name it. Here's your Modbus master diagnostics that you get, any kind of hard slave, EIP, your IO rack. Okay, so you get your IO rack diagnostics here off the bat. Everything's okay. It gives you firmware rev. Again, the PLC is here. Everything is hot swappable. These modules are hot swappable. Okay, and then one cool thing that I want to show you is the door. I'm going to walk over there to the PLC itself. Right here in the front, I'm not sure if you can see it all that well, but we have an acrylic plate. This acrylic plate, we use it as a security boundary for your TCP/IP connection, meaning that I cannot accidentally pull out this cable. Okay, you have to take this acrylic plate off to remove the cable, which is a security factor there for accidental disconnects. And then our doors here, we have a full swing door that I can completely move out of the way when I'm working on the PLC. Okay, I can remove that door and completely move it out the way, get to my terminals the way I need to get to my terminals. Okay, what you see here is a simplex system, 1 power supply, 1 CPM, 4-slot chassis rack with universal I/O cards. Now we do have static cards, we have DI cards, DO cards, 120 volt 240 cards, pulse in-pull cards. We have all the purpose-built cards. But if you want universal I/O, we have that, and what you see here today. Okay. Now, if I go back to my view, all right, you have my 3 cards that I just showed you. If I have any EIP devices, they would pull up here. I do not currently have any EIP devices connected, but you would see the connection here of the EIP device. Okay. If I want to upgrade the firmware, you would simply click upgrade firmware, and it gives you the different components of your chassis. Here I have the central processor module, the extension processor module for my remote I/O, and a UIO card. Okay, and if I have a serial communication board, it'll show up there, whatever you need. Right now, everything's okay. I'm up to the 150, 151 where I need to be. My CPM is good. I'm at the latest and greatest revision, 151. If I wanted to upgrade this, you would hit upgrade, okay, and then you would proceed with upgrade. And then it'll actually do what I told you earlier. It will send that package to the PLC, excuse me. It'll run the upgrade on its own, and you'll be on your way. Okay. Now, if for instance I did not have a PLC program, say I'm trying to troubleshoot this PLC, I want to get into the program, and the engineer that managed the PLC quit or left, didn't tell you where the program was, couldn't find the program. It's okay. With our PLC, you can upload the project that's running currently on that PLC. You can open it and you can save as whatever you want. Okay, so it tells me controller name, CPLC, the project name that's currently running is CPLC, project version, the last compilation date, last download date. It gives you all this information. That's really, really nice. Okay, but I know where mine is, so I'm going to go ahead, open project. I'm going to go to my documents. Let's go to the CPLC. Here's my CPLC. CPLC1. Hit open. Okay, so now I have a CPLC1 here. Okay, and if I open my project, I can set my controller name. It's already set. I'm not going to change that. But here's where you would set the controller name, CPLC1. Perfect. Configure controller startup. Here's if I want what I want to do if when it starts up. Do you want to just go to running? You want to stop, last operating mode, or last operating mode running? Okay. I just leave it at last operating mode or stopped. That's my configuration for this. If I had to configure redundancy, here's where I would do that. Right now it's disabled. I do not have a redundant partner, but I would enable that if I were to add another CPM. All right. Your EIP ports, your connection ports are here. Okay. I'm connected to my process control network via ETH2. All right. So we have two ports. We have two ports here. Let me show you where they reside. You can see it on the video. I have two ports on top. Port 1 and port 2 is where I'm currently using to connect. And then I have two more ports beneath that. The ports beneath that would connect to my processor or my EPM extension processor module for remote I/O. Okay, so that's that piece. And I am connected to number 2. So let's take a look at the configuration properties of 2. So for 2, I have my IP addresses here set. My protocol binding, I have Modbus slave. Here's what I have to choose from. Modbus TCP master. Right now I have OPC UA selected. I have hard IP, so I can manage that instrument through the PLC. I have OPC UA, CDA ability controller data access, and then EIP. Okay, so that's what I have. Here's my program, and I'll get there in a minute, but let's go to I/O configuration. So if I want to add more I/O, or say if I have the need to configure another channel, here's rack 0, slot 1, okay, rack 0, slot 2, my second card, and my third card, rack 0, slot 3. So for instance, if I want to make a change, if I need to add another tag or a point, all I do is select what I need. I want an AI and AO. Let's go to AI first. I'll show you what that looks like. Sensor type, it's a 4 to 20. I want to enable HART. I do have a HART transmitter connected to the other end of the wire, and then you would give it a description here with your ranges. Okay. If I want, for instance, an AO, same thing. You know, you want 4 to 20, 0 to 20. My DI or DO. Okay. That's where you do that. I'm not going to save that. I'm not going to go through each one of these for the interest of time. I'm not going to go through every one of these configuration. I'm just hitting the more popular ones that you would need to focus on. Okay, and then my mapping here, if you are using Experion, I would go to OPC server. So let's go to the mapping here. Okay, and if you are using Experion, you would, once you're finished with all this, let me show you where you configure the thing. if you want to configure anything in here. Here's where you run your logic. So here's an example of, let's see what this is. Here's some function block. Yeah, so here's a water pump. But again, you have all your library containment here that you would need. You have Honeywell library. So again, data acquisition block. Here's your Honeywell analog input. You have a DACA. You have a PID. Here's the PID. You just bring in whatever you need there. That's fine. And then you make your tie-in there, your logic tie-in. But that's how you do that. Okay. Again, we have all of the logic, all the library containment that currently exists in Experion inside of what you see here in this environment. Okay, so once you're done with all of this, once you're complete with this, what you want to do now is just go back to ControlEdge Builder. I'm not going to save that. You would publish to Experion. So here you would put the Experion server. So my Experion server name is EXP-PKS510SVR. Okay. EXP-PKS510SVR. So you hit publish. Successful. Okay. So now, okay, what does that mean, Dave? All right, so let's take a look. Let's see what it did. So if I open up Experion, from the server. Okay. Let me just go to manager here. And then if I go to, let's go to SCADA controllers. Better yet, let's get it from the actual tag itself. It'll be better that way. So here's the PLC, okay? So let's get it from the tag. If I double click, so this is the temperature transmitter that I have off of the PLC. Okay, let's go to scanning. Let's go to COM PLC1. So here's the PLC. Okay, when I hit that publish to Experion, it gave me all these points automatically. It did all of this tagging for me. I didn't have to do any of that. It did with a one shot. It brought diagnostics. It brought my instrumentation. So here's that temperature. So this temperature that you see here is actually the temperature, if I flip the switch, coming from right here. So the PLC temperature here is connected to this. So if I flip that switch, I should lose data there, just to show you. I should lose data there. Yep, see, bad point. Okay, so now I'm gonna go ahead and flip the switch again and bring that PV back. And we should have it back. There it is. Okay, so not only does it do that, it also, this is cool, you'll like this piece, for those who use an Experion. It gives you a nice splash screen of diagnostics for free. You don't pay for any of this. This out of the box, it comes with this. All right, it gives you platform, seep utilization, minimal use, everything that's running in the controller, utilization form, controller temperature, controller time, mode switch position. It tells you if it's in the remote, stop, or run position. The integration is okay, meaning that this is important. If this LED was to be red, that would mean that somebody made a change in the logic of that PLC and did not publish it to Experion. Okay, so you may have an inconsistency there. That's what that means. So right now, consistency is great. It's green. Memory usage and storage, your Ethernet links and all this good stuff, your power supply modules, protocol statistics, and then your I/O modules diagnostics as well, like what I showed you in the first splash screen. Okay. Now, we have a few minutes here, so what I want to do is take you to the core of the point database system. So if I go, for those of you who know Experion, I'm going to go into Quick Builder and just show you where that resides. For those that do not have Experion, then you would be utilizing the PLC standalone connected to your system, right? There's different ways that we can do that. And if you're interested, those of you who are not using Experion, we can actually have another session on how to use the PLC alone, standalone with your current system. You tell us what system you're using, we'll give you the driver for that. You know, Honeywell owns Matricon OPC. And as you can see here to the right, we have drivers to connect to just about any system, okay, with any of our products. So we'll help you there. Now, when I hit that publish to Experion, okay, I can go view integration. Right now I have one variable. I want to show ignored elements. So here's everything that I've ignored. Okay, I don't want all this stuff to come in, but it brought it. So one day I say, you know what? I want to generate that tag. You hit generate points, add new. There you go. It'll bring it in. Okay, this is with the integration. I don't want any of those points. So I'm gonna leave that ignored. The only point I want is this variable. I brought that in a little while ago. But yeah, here it is here, unmatched elements or tags. It will show you that as well. Your controller, it shows you everything there again. Traditionally, you would have to build each one of these tags independently. Okay, either with an Excel. I used to do it with an Excel sheet, which is still okay, but nothing beats that one shot. Boom, here it is. Don't worry about any grammar, any fat fingers, or anything like that. This fixes it automatically, does it automatically for you. Okay, and then same for the RTU. Same thing for the RTU. So if I go back to my main picture, and I select the RTU instead of the PLC. Okay, again with the RTU, same thing. Okay, here's my general tab, all the points that I published on the for the RTU. Okay, my transmitter that I have connected to the RTU is here. There it is. Okay, everything's here at your fingertips that you need. The CPM, so all the diagnostics of the RTU is here, same as the PLC. So again, consistency. As you saw here, okay, one platform that can handle all devices. So I hit connect. It can handle all of your PLCs and all the RTUs that you have at site right here with one platform. Okay, so now if I go to my other virtual machine, I will show you another method, the heart function. Okay, as you can see here, here's the PLC, here's the RTU. Okay, I can bring that in as well utilizing FDM. So now I can manage the assets that I have connected to the RTU, to the PLC, to the UOC with FDM. No issue there. Okay. It's coming in now, but this is what it would look like. Okay. So you have your dashboard. So again, this is the PLC. You have your dashboard. If you want to configure the device, you want to go to advanced configuration, you can do that. You know, show you where to land the wires and how to configure the sensors. But again, the important thing is that every channel on that PLC, every channel on that RTU, the AIs and AOs and DIs and DOs, has heart ability. It's not like the traditional heart mux multiplexer chassis where you have one modem multiplexing across several channels. Every channel has its own dedicated heart modem for a one-to-one relationship. That's why you're seeing right now. That's why you're seeing, you know, all these tabs open so quickly, because if I had a traditional mux multiplexer system on the card itself, it would take forever, you know. But because it's not, because it's one-to-one, I can go in and service multiple instruments and make several changes without hurting the system. Okay. Any questions? I know we have a few minutes here left. I don't want to overrun it like I did the first session. I want, you know, give you time to ask any questions that you may have there. Adam, you see anything on your side as far as questions?
We didn't have anything come through the chat in terms of questions.
Okay. Okay. Sounds good. All right. So before I close this out, that one tab, I want to show you one more thing over here on the PLC. Now, as you can see here, this PLC looks identical to this device here, which is the UOC, the Unit Operations Controller. Same part numbers, same modules, same everything. If, for instance, I want to use this PLC and make it a DCS, make it a supervisory system, what I can do, I can flash this CPM, Central Processor Module, I can flash it and make it a C300. I can make it a supervisory DCS with the UOC, and you can tie that into your network as well, to your FTE. So it's the same part number, same hardware, just a different intelligence, different personality that we load onto the card itself. Okay, just wanted to make you aware of that piece. But one thing you gain utilizing our PLC is OPC UA, cybersecurity, asset management embedment, you name it. Okay, and before we close, I want to go ahead and close with this segment here, kind of where we started. So this here is 1963. When it comes to controls, we've been in the business for a long time. All the dials that you see on the screen here are Honeywell pneumatic dials. This is during that paradigm of all pneumatics. The true, I call it the true era of wireless. There's no wires. It's all tubing. Okay. And in 1969, 1970, we released the first data logger here. This is a nuclear plant. And we released the first data logger into the market. Okay. But as you notice here, all pneumatic. And then the paradigm shift happened around 1973, where, they were starting to convert a lot of the pneumatics into electronics. So what we've done is on this wall, these are PID, single loop PID controllers that we still sell today, replace a lot of these mechanical dials. Well, because of real estate and room and all this good stuff, that paradigm shift had to happen pretty quickly. So in 1981, 1979, 1980, 81, we released this TDC 2000 or Operators Junior, where we took all of these single loop PID controllers and we converted that into software that resides in this controller, in this station here, in this HPM controller. Okay. And believe it or not, we still have customers that are using this technology today. Okay. It's robust, powerful. Then in around 1986, we came out with Unix, came out with a Unix quad-based system that we had. So now you had dual LCDs, quad LCDs. We had the ability to connect multiples, CRTs. We're not LCDs yet. CRTs to a system, okay? And then late in the 80s, we came out with the touchscreen, the first touchscreen, which was more of an XYR-based infrared touch screen versus capacitance touch. So you had the bezel, you had a lot of small little IR receivers and emitters, and then dependent on where your finger was, you met location X, Y. That's where the target would be, the cursor would be on that screen. Again, this technology is still being used today. Okay, and then the modern refinery or modern control room, not as modern as what it used to be, but most of the time when you walk into a Honeywell install base, you'll see systems like this with OEP, operator enhanced boards or keyboards, and then quads or more PC-based systems, where these systems here are more discrete Unix-based Honeywell proprietary systems. Okay, and in today's current technology is now Star Trek-based. This is the Orion. Right. So as you can see, we've been in the business for a long time when it comes to software controls and process controls. All right, Adam. Well, I'll hand it back over to you. If you have anyone has any closing remarks, or Adam, if you have any closing remarks, I really appreciate each and every one of you. I wish I was there in person. These systems that you saw today on my camera are the systems that I would take that I will take and do take in person to sites to do live sessions and demos. So we can set one up when all this is over. We can still do that. I wish and everybody good safety, good health, and I hope your families are okay. And if you want another session just on a niche topic, please let Adam know, and we will get that scheduled for you, where we would just do a topic on a certain thing and spend some good time just with that. So with that, I'll hand it back over to you, Adam. Thank you so much for setting this up, buddy.
Yeah, thank you very much, David, for hosting. That was really informative, and I think you did an excellent job with hosting hosting this at home. I'm sure everybody's kind of seen a couple of the videos online of some people struggling with this working from home. So really appreciate that. I really appreciate everybody taking the time to join us for these 2 hours. Just to kind of parrot what David said, if anybody has anything that you're interested in tackling in more detail, obviously we can't take David to your site at this time, but we do have a fully functioning demo set up at David's house that we can walk you through, like you said, a little bit more of a niche application. So don't hesitate to ask. We're trying to adjust as quickly as possible to the state of the world right now. So anything we can do to support you in your process safely and effectively as well, we would be happy to do it. So thanks again to David. Thanks again to everybody to host for joining. I will distribute the recording. And like I said, if you have any interest in a follow-up session, do not hesitate to reach out to one of the TK team members, and we'll be happy to set up something with you. Thanks again for joining, and stay safe, and have a great day, everybody.
Thank you. Thank you, everybody. Bye-bye.